All right, you guys, let's continue our discussion on vectors. So this slide says the unit vector. So a unit vector is a vector that has a magnitude of 1. Okay, and two very useful unit vectors are defined as I, which has horizontal and vertical components 1 and 0, and J, which has horizontal and vertical components 0, 1. So IJ forms for the unit vector. So remember, there's a bunch of ways now that you can represent your vector, either a bold-faced letter, you can write it using its horizontal and vertical components. You can also write a vector now using the unit vectors, okay? Where A and B are still your horizontal and vertical components. It's just you're attaching I and J to those as well, okay? So let's continue our discussion. Let's look at the dot product. Okay, so earlier we looked at operations on vectors, and we could add vectors together, we could subtract them from each other, we can multiply them by a scalar, but we didn't talk about what happens when you multiply two vectors together. When you multiply two vectors together, that is when you get the dot product. So if you have the dot product of two vectors, it becomes a real number, not another vector. So be careful about that. When we added two vectors together, our result was a vector. When we subtracted vectors, our result was another vector. When you multiply, you do not get another vector back. You get a real number. So be careful for that. So the dot product is defined. So it says the dot product of two vectors where u equals AB and v equals CD is denoted by u dot v, okay, and given by the following equation. So u dot v equals the horizontal components of both u and v multiplied together plus the vertical components of both u and v multiplied together, and you're adding those two products, okay? So your end result is going to be a real number, not a vector. So if we look at this example where we're asked to find the dot product between two vectors, so the first one is 2, 3, and the second one is 4, -1. All right, to get the dot product, you multiply the horizontal components together and you multiply the vertical components together, and then you add those together. So your answer for that would be 5, okay? So you're always going to get a singular answer for the dot product, okay? All right, so some of the properties of the dot product, okay? So it says for all vectors u, v, and w and real numbers k, all right? For A, the order in which you do the dot product doesn't matter, okay? So you can do u dot v or v dot u, you will get the same answer, okay? For B, you can do the dot product between a vector and then the sum of two vectors. That's the same thing as doing the dot product with each of those vectors individually. And for C, it's the same as B, except the order doesn't matter. Okay, for D, you can also multiply a vector by a scalar and then do the dot product. Okay, for E, you can multiply any vector times 0, do the dot product between 0 and a vector, and you will get 0. And the dot product for F between a vector and itself is the magnitude squared. Okay. All right, now the dot product has some special geometric interpretations. So it says if theta is the angle between two non-zero vectors, u and v, where theta is between 0 and 180 degrees, then the following holds. So you have u dot v is equal to the magnitude of u times the magnitude of v times cosine theta, or you can rearrange that formula to get cosine theta equals u dot v over the magnitude of u times the magnitude of v. Okay, so we're going to use that formula in the following problem. Okay, so the directions say find the angle between the two vectors u and v. Okay, so the formula that we had above said, well, if we want to find the angle that falls in between those two vectors, we're going to use this formula. Cosine theta equals u dot v over the magnitude of u over the magnitude of v. Okay, now anytime I'm using this formula, I go ahead and find the individual parts and just plug them into the formula. It makes the work a lot neater instead of trying to do it all in one place. So the first thing that I'm going to find is the dot product, okay? And the dot product, I'm going to multiply my two horizontal components together. And I'm going to multiply my vertical components together of my two vectors and then add them together. So 2 times 3 is 6, 4 times 1 is 4, and 6 plus 4 is 10. So that's the top part. Okay, then I'm going to find my magnitude of each one of my vectors. So remember, magnitude is defined as the square root of a squared plus b squared. So for u, that would be 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. So that's going to give me the square root of 25, which gives me 5. Okay, and then I'm going to find the magnitude of v. So same formula. And I'm going to plug in the horizontal and vertical components for v. So that's going to give me 4 plus 1, which is the square root of 5. Okay, now according to our formula, we're looking for the angle that falls in between. So this says cosine of theta equals 10 over 5 times the square root of 5. Now, I don't need to worry about rationalizing this because I'm not interested. This is not my final answer. I actually need to use the inverse cosine to find theta. So you can rationalize it if you want to. It's not necessary because it's not our final answer. So I'm going to use inverse cosine. 10, 5, square root of 5. And I'm going to plug this into my calculator, okay? I'm going to make sure that I'm in degrees. So when I go to plug this into the calculator, in degrees, this happens to be my answer. 26.57. I'm going to round to 2 decimal places. So theta equals 26.57 degrees. Cool.